2.7, you can see that a two-dimensional drawing of an object in which the dimensions of the drawing are proportional to the dimensions of the object. This is called a scale drawing. A three-dimensional model, so drawing model. A three-dimensional model of an object in which the dimensions of the model are proportional to the dimensions of the object is a scale model. Here's centimeters. Use a metric ruler of the map of Ohio to estimate the distance between Cleveland and Cincinnati. Cleveland and Cincinnati. So, let's say about 3.1 centimeters. So the distance between Cleveland and Cincinnati is about 3.1 centimeters. We have a ratio right here. It says that 1 centimeter is going to be equal to 85 kilometers. So we have 1 centimeter is to 85 kilometers as 3.1 centimeters is to X. Again, it's important that if centimeters is on the top, then centimeters should be on the top over here in this ratio as well. All right, we're going to cross multiply and we get 1 centimeter times X. 85 times 3.1. 263. 0.5 kilometers in centimeters. Centimeters times kilometers. To get rid of your units, you could just divide those units out. Divide by centimeters. Divide by centimeters. And you get that X equals 263 5/10 of a kilometer. Each day, the seals at the aquarium are each fed 8 pounds of food for every 100 pounds of their body weight. So there's a ratio right there, 8 pounds of food for every 100 pounds of their body weight. So we have 8 pounds of food to 100 pounds body weight equals a seal at the aquarium weighs 280 pounds. That would be body weight. So we have 280 pounds. How much food? Food, that is the unknown. All right, cross multiply, we get 100 pounds X. And then 280 times 8. We have pounds and pounds. Divide out 100 pounds, out 100 pounds. We can see that one of these will cancel. We get X equals, dividing by 100 just means moving the decimal place twice. So 1, 2, that would be 22.4 pounds. Okay, now these next ones, these proportions, you need to be careful because now we have more than one term in the ratio. This is not like the simple ones that we did. These ones are a little bit more drawn out. Again, you're going to use that same technique of using the cross products. We have 7 times X, 7X equals 3 times 2X plus 5. This is the place where students will make a mistake in setting it up. It is 3 times 2 things, 2X plus 5. You're going to be seeing the distributive property here. 7X equals 3 times 2X is 6X, and 3 times 5 is 15. All right. I see that I have variables on both sides of the equation. Remember, we need to keep this balanced. I would like to shift the 6x to the left-hand side. That means I will be doing the opposite of 6x. I'm not solving right now. I'm still trying to simplify by collecting my variables to the same side of the equation. So to shift the 6x across the equal sign to the other side, I need to do the opposite if I'm going to put it on the opposite side. The opposite of 6x is negative 6x. And we're left with x equals 15. Problem C. Four times 3m plus 6. Seven times m plus 1. And now we're ready to use the distributive property. 4 times 3m would be 12m. 4 times 6 is 24. 7 times m, and 7 times 1. I see that I have variables on both sides of the equation. I need to shift my 7m over to the 12m. I need to shift 7m to the opposite side of the equation. I'm going to use the opposite of 7m. We get 5m plus 24 equals 7. I have a two-step equation. I am ready to start solving. I do my 24 by subtracting 24. And just dividing out, get m by itself, and we get negative 17. Yes. Done. We have 8 times 8 is 8a, and then 1 times 9a minus 2. 1 times anything is going to be itself. 1 times 9a, 1 times negative 2. And I'm going to shift my 9a over to the left. 8 minus 9 is negative 1a equals negative 2. Am I done solving for a? No, you cannot leave it negative. It's being multiplied by negative 1, so I could divide negative 1. We get a equals 2. All right, cross multiplying, we get negative 5 times 16.5 plus 3t equals 3 times 0.9 minus t. All right, starting with the distributive property, 16.5 times 5. $825 with one decimal place, 82.5. So negative 5 times 16.5 is going to be negative 82.5. Negative 5 times 3t is negative 15t equals 3 times 9/10 is 27 with one decimal place, so 2.7, and 3 times negative t would be negative 3t. Now that I've gotten rid of my parentheses, I'm ready to start shifting across that equal sign. Let's see, I'm going to bring the 15t over to the negative 3t. So add 15t. Usually at the same time, if I'm shifting my t's to the right, that means I want to be shifting my numbers to the left. So I'm going to do that at the same time right now. I have 2.7, a positive 2.7. I want to put it on the opposite side. That'll be negative 2.7. Negative 2.7, lining up your decimals. All right, we have negative 3t and positive 15t. 15 minus 3 is 12t equals I have here is two negatives. So I have a negative plus another negative. I'm going to add them up and keep the same sign. So that would be 12, carry the 1, 5, 8. Break down my decimal, and that's negative 85.2. Divide by 12, divide by 12. T equals whole number here, decimal up, 7, 84. Subtract, and last number works out evenly. We get T equals